Hi, everybody. Thank you very much for joining us. Welcome to the first show and tell stream. This is going to be an interactive experience, so if you have any queries or questions, please do post them in the chat and I will try and pick out some good ones. Please be respectful to everyone, and if you think you might like to come on this show yourself, please do get in contact. There are details about that on my channel's About page. Today's guest is Timon. Timon, why don't you introduce yourself?
Hello, I'm Timon, or Timonsku on Twitter. I'm an engineering generalist. I do electronics, mechanical, software, everything. Sometimes hacky stuff, sometimes producty stuff. Yeah.
Very good. Thanks for coming on.
Yeah, pleasure to have me.
So we were talking before, and we were talking about education and sort of the beginnings of Timon, how you got here. So you mentioned that you started off quite keen on computer effects, animation, that kind of thing.
Yeah.
Do you want to just touch on that quickly?
Yeah, sure. So I was not like one of those kids who started super young with like software and electronics and like destined to be an engineer. I was always kind of technical and a nerd and but more like, how do I get my Windows games to run? And I was more in like the creative side, I guess. Like I was really into photography and like drawing stuff as a child, and I kind of set my path onto like motion graphics, visual effects for like movie kind of stuff.
Mm-hmm.
And right after school, I started a job at like a small animation studio, and I did that to like get experience in for a special kind of university that needed like a year or so job experience before I can apply. And after working for a year, I didn't really feel like studying because working was fun and it pays.
Fair enough.
And yeah, and that job, we had then one job that kind of required programming. Wasn't a completely foreign concept to me. I did like some C++ course when I was 11, but I hated that. Same with soldering. I did some electronics kits, but yeah, I made them. It did something. I didn't understand them.
Yeah, it's easy when you're young, isn't it, to not really get what it is you're doing and have this sort of.
I mean, back then, also these resources were bad. It's just there was nothing that explained the circuit. It was just like, here's how to solder it, and then it does that thing.
Yay!
no concept of like what is actually going on. How does it work? Like there was nothing to learn. I don't know. Maybe there was a book to buy or that we missed. I don't know. But back then there was like pre-Arduino times,
yeah.
So yeah, but yeah, in that job I was, I think, 18, 19. We had this customer who wanted some interactive thingy, and it was a small studio, so they just said yes to it because we didn't have many things to do. And I did this like prototype for the software side with like this Quartz composer for Mac, which is like this graphical programming language.
Okay.
We then got a freelancer in to like do it properly, and I was kind of mad that my pet project was taken away to like the pro. And
so can you expand on the interactive project? Like what was it? Push a button and the lights come on, like a diorama?
It was a simulator for colors. So like it was a color company that makes colors like for painting. And they wanted like a small like display room where a projector would like project colors on the walls to like simulate the color range. I think the concept was flawed because it doesn't really work with projectors. But we did it. And it needed some like interactive thingies, and like it was basically a projection mapping application.
Okay.
And yeah, that kind of frustrated me. And like I had probably the craziest learning sprint in my life, where like over the weekend I would learn C++ and did the whole thing again in C++, the projection mapping thingy, and
then it got
using the freelancer code because I just learned it. But I was then assigned to like, okay, you can take it over after him and like fix stuff, and if we need more features or whatever. I don't know.
Yeah.
But that freelancer showed me then also how he would implement all of the kind of control buttony thingies, and he like pulled out an Arduino and showed that to me. And because I already had that and then learned C++, I was like, oh, cool, that seems familiar. It seems easy.
Yeah. Nice.
I learned Open Frameworks, which actually has a very similar kind of like paradigm of like having that setup code and then the loop code where like you just fill these things in and then it works and does some magic in the background that you don't have to understand right away. So I felt very familiar. And then I got started with Arduino, and I don't know, having that like first LED blinky working and like understanding, okay, cool. If I change that code, I change that physical light.
Yeah.
That
I
was
remember
like
that feeling as well. It's just
mind-blowing realization of like, okay, if I can do that, there's so many
what
things
else can I do? What can't I do?
like seeing, okay, a motor thingy is okay. You just this one pin, and you do like some wiggly stuff with the pin, and then the motor does something.
Yeah,
You know,
yeah.
now you have servos. Now you can actually move stuff around. Like, like it was hacky, but like you kind of made that connection of like, okay, if I get better at this, I can do things.
Yeah. So would you say that project hooked you and you got really quickly into this field, or was it more of like a slow burn where the project ignited your imagination almost, and then like over the next year or two, maybe you got more and more into it?
Yeah. I mean, I asked my father to like buy me a kit because I didn't make much money at that job, and they were quite expensive, like 80 euros or something back then. It's actually Fritzing, yeah. Maybe you know the tool Fritzing. They sold kits back then. That was my first electronic kits. So I guess, I mean, they were expensive probably because they sponsored product development for that. I don't know. But no, it was like, yeah, I kept at it. It was interesting, but I wouldn't say it was like, okay, now head off to being an engineer. Programming, on the other hand, yeah, that kind of was more, I think, the more overlying path that came up for me. And I was then switching jobs to something that felt more in that direction, because I was like, okay, the animation industry is kind of shitty, very, very bad working environment,
lots of stress and things, I guess.
Yeah. I saw all of these colleagues around me, all these freelancers who are constantly broken down. It's like, I don't want that for me.
Yeah.
And that was around the time where like Life of Pi came out, and they was demonstrating the visual effects people in front of the Oscar presentation. I was like,
amazing.
Okay, nope. So I switched to this other job in the area, and that was like media system design, where like I felt like all of my skills came together. Okay, they do a lot of media visual stuff. They're actually doing a lot of After Effects, which I know, but they also do a lot of electronics and software. So seemed like a perfect fit. Switched that, and that's where I worked for the past 9 years until last Friday. Actually.
Congratulations on your new job. Let's get onto that again a bit later, I think.
Yeah.
Can you give us an example of like maybe a project or sort of a scenario for the media systems that you did?
Yeah, so like in the beginning was a lot of car stuff. I was until the pandemic, I would say. So like in the beginning, it was more like, okay, you can do like After Effects stuff and like electronics, and like slowly I would do less and less visual After Effects stuff and more software and electronics. And
so it feels almost like in The Mandalorian with their I can't remember what it's called, but Unity and everything on the massive LED screens. It feels almost like sort of a baby version or an early version of that potentially, where you've got After Effects mixed in with the electronics and the real world stuff.
Oh yeah, I guess. Yeah, I mean that we actually worked with the technology that they use in the Mandalorian. Yeah, in Unreal Engine they do that. Yeah, it's like it's a very it's always hard to describe that job because it's applied in so many fields. So we did like showrooms for like a doctor's office, which is like okay,
a bit random, yeah.
But like everything where you are in a space and you interact with something that is digital in some way. A lot of times that is light. We did a lot of concept cars for like if you go to a trade fair and see some really crazy ass concept car, that's maybe something I did.
Nice.
For like Kia, we did this like had this concept of with like a dashboard with like 21 individual phone screens. Looked like a stegosaurus, and like showing one rendered picture along it with like a live application that was doing rendering on that. And
was it 21 computers behind it effectively?
6 computers networked together and like 21 HDMI cables going from the motor into the front cockpit.
Wow, sounds fun. Still a bit crazy.
Yeah, it was a very fun project. But I also do like museum stuff where like, if you have like media screens and they can do something and like get something explained and like play with something does something. That's kind of the stuff I do.
Yeah, did. Very cool. Nice. So moving on from that, then you have a new job. Congratulations again. And this is more of a product design job. Is that right?
Yeah, so like I was doing Pioneer past year, like launching my own company and launching a product, and
Yeah.
I enjoy that, but I didn't want to have that be my source of income, because it's more
Your
like I
responsibility.
realize my hobby.
Yeah.
And if you want to do product design, you kind of have to bring it to market, unfortunately. Like
Yeah.
having it sit on the shelf is kind of useless as a product. So make it
It's a shame, isn't it? Okay.
Yeah, so like, but I wanted to go more into product design, because actually the media system design job, a lot of the process there is product design, actually. Like a lot of times is, the concept cars were product prototypes.
And I guess a lot of those were effectively like one-off, and that's why it's
Yeah,
not
it's
necessarily
one-off
considered product
prototypes.
design, because you're not producing all the files to produce many of them.
Yeah, exactly. It's like the stage before
Yeah.
DFM and like anything where you like figure out what it should do, how it should interact, and like get a feeling for the product. So like you do like the initial engineering, where it doesn't really matter how, you just have to get it to work very quickly.
Yep. Make it happen, etc.
Yeah, and it's fun. It's can be fun. It's stressful, but it's fun. But I'm really interested in like the whole cycle of like concept, thinking about stuff, design, and then, but all of the hard stuff of like manufacturing it and bring it to market, and like what do I have to actually do, like certification. There's a lot of stuff that goes into that I find.
So if we start off then in that whole massive process of getting a product to market, with the design at the beginning, you've done your Pyrona. Apologies, I'm probably pronouncing it wrong. What did you do at the beginning? Did you have to take a lot of careful considerations with your design, or did you make a prototype and learn from it? How did that come together?
I kind of thought like the idea came from Skerutsch. He just mentioned in some stream chat that like, hey, it would be cool if like somebody make the Compute Module 4, but in like some Arduino-ish form factors, like something electronicsy prototyping, because he was interested in porting CircuitPython to like bare metal Pi, like without Linux. And I thought, it sounds super easy. Like I worked with a Compute Module 4 before, like did some prototypey stuff, and just sat down on a weekend and churned out the first prototype, and
just like that.
That was there's a lot of like learned experience of having like a library behind that. So like,
of course,
3 days with like 6 years of experience doing that same stuff behind it, just a week. Some people get like flustered from that, hearing that.
Sorry.
I just reused a lot of like, there's a lot of reused knowledge in there. Less to figure out, and I already figured out the Compute Module 4. I had my own footprint for it. It was just like dropping it on the
really good starting point.
Open source boards. I used just some Adafruit template for that, like other Adafruit Metro board. Ripped it all up just to have the outline for it. So like, it's a nice thing about an open source. You can get started very quickly on new things. And that was like, try it out. Posted a picture to Twitter once the PCBs came in, and people were super excited about it. I was like, like I already had experience producing hardware for the day jobs. Like, while we don't do mass market things, we do product runs for like 100 pieces. And so like I already had established relations with like a PCBA manufacturer, and was like it kind of set up already to just do it. At least the manufacturing side of things. And I always, I did that whole like Linux tablet prototype in 2019 for the Hackaday Prize. I won that, and like people were very excited about that. I kind of got stuck on like, okay, I can't go really further without committing to like commercialization, because it's a very complicated product. A lot of money would go into it. I can't just do that as a whim. It's fun, but like it's too much of a burden to like not have it, become real. And I kind of got stuck there because I didn't want to fund a company. I was, full-time working, and it just felt like too much. It was such a huge project. And Jenner came along and was like, hey, that's easy. I know how to do this. It's just a PCB.
I guess the fact that it is just a PCB means it's not got an enclosure. I don't know the rules. Maybe you're exempt from EMC, that kind of thing as well. So it's more of a dev kit than a.
It's not EMC exempt in CE, unfortunately. It's kind of weird because they don't really have good guidance for these kind of products whatsoever. But it's not too terrible. But so like, no enclosure, like it's just packaging, PCB. That's it. It's like I felt I knew it was going to be a lot of work because there's always a lot more than you think. But it's always good to start something with something that looks very easy, and then be surprised with more stuff. Then start something, I could probably get it to work, and then it's like so much more
problem after problem.
Yeah. So that seemed like a more sensible thing. So I founded a company, and I talked to crowd supply, get a campaign going to get the funding in, and just went from there. I talked to my manufacturer, and I think mostly what I did, the Pioneer that came out is 90%, I would say, the first prototype.
Okay, well done.
But there were several weeks of design and research to do still. Well, the last 90% of really fiddling, finding out these corners and everything where people get stuck on. One feedback I got was hey, how do I actually, which orientation should the compute module 4 have when you put it down?
Okay.
Here's it's kind of just a rectangle, and it looks on the first view, if I pull it out, like it's almost symmetrical, but only almost.
I was going to say, I thought it was a bit pokey, but
having some guidance on where it should go. So put that arrow here where the Wi-Fi card is actually also making that arrow.
Gotcha.
So having some visual reference, for example, it's small things like that take time and considerations, and that's where most of the design time went into. And still, I would say R&D was maybe 2 months total. It was full-time work. And everything else was signing contracts and manufacturing. And
so I was going to ask about that in terms of selling a product. What does that really encompass? How does that feel now that you've done it?
Great. It's very cool to see it being sold on huge retailers like Mauser. You can buy it everywhere in the world, and it's on Adafruit and Seed Studio, and all the places that I buy my electronics from.
Yeah, exactly.
My products there. And people do stuff with it. It was really cool. It was incredibly stressful, but very cool.
Yeah, brilliant. So we're talking earlier as well about things like the time pressure involved in projects. I guess Pioneer was perhaps a little bit less pressured, or is it a matter of you put these renders out there, and all of a sudden there's this maybe even sort of perceived or self pressure to do it before someone else does almost. How did that go?
Yeah, that's true. And I already have my first clone. Waveshare did a clone, not a complete clone, but a knockoff of the product shortly after launch.
I saw that.
I was expecting that to happen. It's not. That's the thing. Open source, people are always afraid. If I put the source files out, people will instantly clone me. Yeah, it's very possible, but it will happen either way. Yes. They didn't make a direct clone, but it's still a complete knockoff and competitor of me. It's fine, that's not what you should worry about.
Okay.
And I took my time. I knew what I was doing and what I wanted and what my value is. There's support there. There's software there.
All your documentation and things.
Documentation, and I know what to write. I have huge experience with the Pi platform itself. I did that for 10 years with all of the media systems. A lot of that is Pi stuff.
Okay.
And, so I know where people have issues with. We have interns that, here's a Pi and here's some software, please get that started. I know where people have issues that are not super into the ecosystem already, or Linux in general. So that's something that's my offering. It's not essentially the hardware. It's my hardware is tied to my software support and my documentation, and that's what you should worry about. If somebody, if somebody made the knockoff before me on the market, so what? That's really that didn't worry me. It took me a year in total from okay, here I have a thing, I make this a product now, to okay, now I can actually. It's being shipped to customers. That was about a year.
Okay. And so now that you're in the crank the handle, as it were, phase of the project, is this mostly Timon's handoff, or are you actually quite involved in getting parts in and distributing them to your distributors, etc.? How does that work?
I tried from the very beginning to set it up in a way that I'm not involved too much. So there's a lot of different approaches. Some people get the hardware shipped to themselves and they test them themselves at home, which you can totally do. Is more control, and if you don't trust your manufacturer, maybe with testing, it's valuable. But I do batches of 1,000 pieces each, and testing that is a ton of work. Not viable for me.
So presumably you've done jigs and things and documentation as well to deal with the testing, and
that is a ton of work. So that's communication work towards the manufacturer. You have to explain your product, you have to explain what is important about it, what they should take care of. For example, I specified that these pin headers, they need to be perfectly straight and nice. Quite often pin headers are soldered on a little bit at an angle where it's completely functional. It will, you can put the shield in, it works, but it looks not well. It looks kind of shoddily. And communicating all of that intent, it takes a lot of emails and time. And same with the jig, how to test it and getting them up to speed on that. And but I think it's worth it depending on the scale of things. And in my case, definitely, I'm very glad I did that work, because it's one-time work, not something that's completely repeating. So now they can just instantiate new batch, what to do.
Yeah.
And they just come to me when there's, this part is out of stock. What should we do? So then I have to look up alternative parts, which is annoying, but it's a manageable aspect. So that's really the only thing I do is communicating with the distributor, order something, then I tell them to okay, here's some labels, please put them this many things in a box and put these labels on and send them to this place. It's kind of the extent of what I have to do.
Nice. Sounds like it's set up well.
Yeah, I highly recommend doing it if you plan on continued sales and a lot of sales. Painara is not a high margin product. I priced it a little bit on the lower end for that type of product. Some people sell their carriers for 130 euros, which is totally valid, because it's more of a niche product. But I want it to be accessible while still being I can maintain it. Finding that sweet spot. That was hard. Actually, finding out pricing, that took me weeks. That was pretty tough.
It's something that I've struggled with as well, is how to price your stuff. It's not easy.
Yes.
Do you get now that you've got this product out there in the wild, do you get people going and getting one, contacting you saying, look what I've done, this is amazing, or I
have a Discord where sometimes people post some people made cases for it, which I think is cool. People makering around it, and somebody made remember the Motorola laptop, which was this laptop without a brain, basically, just keyboard, display, and battery, and you could put your phone into the back of it.
Oh yes, yeah.
And then it became a laptop. Completely failed product, but a fun idea. It was too early for its time. It was 2012 or something, I think. But they had that around, and apparently Pioneer is a perfect fit for that, because you can actually power it through the USB-A port.
Amazing.
It's not very USB compliant at all. That should not be possible. But I know makers, and I know that is one of the most annoying things is USB ports crapping out at 500 milliamps, even though you have much more power available. So one of the other considerations, when do you need protection? When does it become annoying? Because a very detailed question of what's the audience. For a mass market consumer product, that USB port should definitely have power protection. For this kind of R&D type product that targets engineers, I don't think it's necessary or helpful at all, because you know what your power supply is.
Yeah, fair enough.
But so they made a laptop of it. Kind of random thing, but you could just plug it in apparently and worked, which is cool.
Magic. So you mentioned their mechanical design. You've done a bit of dabbling with that as well.
Sure.
You did the cases for Glasgow and Luna, I think. You happy to talk
about
that?
My day job was very. I'm a generalist, I would say. I'm not an electrical engineer. I would say I know a lot about that, but it's I always learned the things that I needed for the job. Basically, that's how I got into all of these things. And at some point, I learned fusion because I need to do mechanical design. CNC aluminum milled cases that I did for Luna and Glasgow.
You look brilliant. Well done.
Thanks.
So for these, did you have? I don't know if you've contracted out the CNC type milling and work before, or is this again new experience that you learned to support these products?
So yeah, I'm grateful for my job because like I've done basically everything at some point.
Okay.
It's very little that I haven't done.
Okay, so this is included
which is
in
a
the
blessing and a curse. But yeah, I've already had contacts for manufacturing there as well, and I was just doing that again with the same people.
Very nice. So we mentioned it briefly earlier. A big topic is communication, and we've touched on it a few times. You know, talking with your manufacturers for the Payunora, we talked about it about you know, day job with getting customers and keeping their expectations in check, that kind of thing. Is there anything in particular there that that stands out to you that you feel maybe is
Yeah, I think the biggest takeaway in general is like having empathy for the other side, and know where people are coming from. We tend to talk in very specific ways. We have our words in our industries, and we have our biases on how we think the world works and how things should look. And what I notice is quite often that gets in the way where like you just skip over certain things, like
a lot of assumed context and things like that.
Yeah, exactly. It's like with the manufacturer, you know, like they do a lot of things, like making sure that these headers are like super neat in 90-degree angle perfectly. Like that's not a normal thing for them. Like why should that matter if it's 88 degrees or something? And you know, that's all of these assumed bias, because I know as a dev bot, somebody will have this in this format. There's no case around it. It will all be visible. So all of a sudden presentation is important for you. It's obvious because, you know, clearly this is a dev board, but it you know, it might not be for the manufacturer because they do a lot of other things, you know, while the maker industry is big and dev board industry is big, but it's not that big that it's like everyone has a clear understanding of these things. And that goes really for everything you produce. Is like communicate your intent and communicate it clearly without assuming too many things. It's always hard to find out what not to assume because, you know, but that's part of what I mean with empathy, of like, where do they come from? What this might be clear to them, what might not be clear to them. And same goes with customers. I worked a lot with customers who are purely designers, who are have ideas for something, how something should look, how something should feel, but they have no idea what they're asking from a technical aspect.
Possibility and various other things as well, I'm sure.
Yeah, and then you have to like figure out, okay, what do they actually mean with what they're saying? What is actually important there? And if they say something that's like maybe technically not feasible, either time or budget wise, or just from like physical standpoints, what is important? What can we change without, you know, destroying their intent? So like there, I feel like, you know, having worked in kind of the design industry, I guess, you know, kind of help empathize a bit more for like, people who come from more of a conceptual side or design side.
I think it's so important, as you say, to consider both sides, but also to consider the, you know, when I am talking, or when you are talking to your manufacturers, for example, being on their side of the fence is similar to when your customers are talking to you. You know, your customer in that relationship has the idea. They know what they want, and they've got to communicate it with you. So being sat in the middle is really important to remember that actually, you know, that there's two sides to this coin.
Yeah, absolutely. Yeah, and like, also don't assume they know everything. It's also a thing where like I feel sometimes people, especially with manufacturing or even with designers, like there's a little bit of not everyone, but a lot of engineers have a bit of an elitism to the attitude sometimes. We feel like, okay, I do very smart things and I, you know, very involved things, and like I know stuff, so like I probably know better than them. And you know, you have your problem space, but you know, the design problem space is also important. And like, you're not always the most important person there or the most knowledgeable person. Like sometimes people know other things that are also very important in this specific instance. And same with manufacturing. Well, like, yes, you know exactly what you want to make, but there's a lot of realities to manufacturing that you might not be aware of. So like, see your manufacturer as your partner, not just some faceless drones that do your bidding. I feel some people have a very weird attitude in the beginning of like, treat them like this big faceless Amazon company, basically. Like they're just people who try to do the thing you made, and you can communicate them. They can understand things. They can understand what you made. You just have to say that, and try to communicate. And even with the language barrier, like sure, there, I produce mostly in China because a lot of know-how is there, and there's a language barrier there, of course. So sometimes words don't have the same
meanings, or exactly,
because I learned English a little bit different. I learned some words in English where, like, I'm German, so like when I learned English, some words I only learned by context. So like, I think it's even with native speaker probably, like, there's always some miscommunication happening. So it's always finding out like how can I break very clear, like use pictures and drawings and stuff like that to like make your intent clear.
So that for me is a super important tool. Is diagrams, drawings, etc., but also bringing a concept or an idea into the realm of what's already familiar with the person you're talking with. And so when you're talking with, you have the idea and you're trying to give it to someone else, it's important to rephrase it potentially into something that they may already be familiar with. But also when you're trying to listen and receive an idea, it's important to actually sort of take a step back and listen. Don't just sort of jump to the assumption that, oh, they're talking about this. It's really important to take a step back.
Absolutely. Like for the tester, for example, by Nara, I made a complete video of like how to do it. I didn't write a text with the stack. Like I think maybe they also did that, but like, video really shows what you mean, like describing these things, like mechanical steps of like, okay, put it like this and then press the button.
100%.
Doing both, like try all the ways. It's super helpful and ensures that there's no miscommunication. And especially if you make a lot of things, a small miscommunication can cause a lot of trouble.
Absolutely, yeah.
So look into that, question yourself, question how your
own assumptions,
communicate something. And always ask twice. If you're unsure if there's someone got your intentions correctly, like have them rephrase it to you, and see if they repeat it in a way that makes it clear for you. Double check.
Sounds like you might be a good teacher. It's one of those things that I very strongly feel that we as humans are not very good at, although a lot of the time we think we're quite good at it.
I get into a lot of misunderstandings still. I've been at this for a long time. I'm still like, it's a constant effort.
Yeah. Very good. So we mentioned education and things earlier. This is something that's a bit potentially, I don't know if the word is divisive, but people have opinions and things about how to get people into a particular space. Do you have any particular thoughts that you might like to talk about now?
I mean, like, I'm so mostly self-taught. I had my brief intermission in university, while I was working. Mostly back then, I was like, okay, if I want to do like this electrical stuff, like I need some degree or something. I need a piece of paper to like be taken seriously. And that was especially in Germany, like, it's very. I can't call myself the German word of engineer because it's very protective and like you have to have studied to do that. So like I'm an engineer, but I'm not the German version.
Okay.
But
is that frustrating to you? Is that something that you actually kind of respect, or is that really not okay? Almost.
It's a very difficult topic. I think it depends. Like, of course, there are security conscious systems. There are spaces where it's very important that the person doing it actually knows what they're doing and
100%.
are not lying about it. So like there needs to be some form of checking if they actually fit for the job. I have big doubts that the university is helpful in that regard anyway, because
in terms of the students they're producing, or the
yeah,
graduates,
and I know what we learned, and I know what the people that continued. I broke the university. I stepped out, but I've kept contact with them. Like, and what I hear so many times in all of like engineering studies, even if you do a master, like people don't feel equipped for the job world, because you learn concepts and mathematical concepts, especially, and like you learn academics. But you don't, I feel, quite often learn engineering necessarily. So it's very hard to apply all of these academic concepts into engineering, and I feel a lot of the times you don't seldomly need these academic concepts to do the engineering.
So not quite the same thing, but I do remember when starting uni, a lot of people were used to getting spoon-fed by school. Here is a problem, do it. There is a correct answer. Come back and see if you get it right. At university, it's a lot more self-led, and in the real world, there's almost no guidance almost for some things.
There's no hand-holding. I feel like these days university, at least here, is a lot more schoolish. It's a lot more feeding spoons a little bit to a degree. But yeah, totally. What I feel like university most lacks is teaching people to learn. Like how do I learn things? How do I learn something that is not something I already know, or that's like clear how I learn it? Like how do I find the resources for it? How do I teach it to myself?
There's a certain amount of interest as well. Well, certainly for me, if I'm interested in a topic, I will just devour it.
I mean, motivation is also, like, of course, a big impact there. But still, like, I feel like most of the time, like whenever I had to teach someone coming to us as an intern from university, like they were in their last semester or something, and most of the time was like either the people already knew how to learn things, like they figured that out, or they are completely clueless about that and have to learn that at the job then to like, okay, here's something that I don't know. How do I know? What do I do?
Approach it. Where do I start?
And like going back to that, like I feel like university it really depends on the field. I don't want to like have an all-round opinion on how it should be, but I feel like a lot of university degrees are not equipped for what people then expect to do afterwards. And I feel, especially when it comes to like these things with like, okay, if somebody went to university, they know these specific things. I don't think that's true. It differs so much between university, between country,
or even individual. At the same university on the same course, then individuals take a hugely different thing.
Maybe some subtopic was a big thing in that one course, and another university was just like mentioned in like a sub-sentence. It differs so widely. I feel like when it comes to like, okay, certifying that somebody knows something, I think we should approach it very differently. We do that a bit in the in the software industry, where like it's there are so many certifications from different, mostly by companies. It's not perfect. I think there's a lot of issues with that too, and how that is done. But I think it's a bit more useful because you have a much more clear understanding of what people then actually know after that, or like have certifications for certain things that are more specific to certain fields, certain industries, and don't tie it so much to universities, because universities, they just teach you some basics at the end of the day. It's a foundation for something, and
and what's really, really important to remember is that actually for so many people, universities aren't actually required or particularly important. It's a route, but it's not the route.
Exactly, and I think that's, for me, I thought, okay, if I want to be an engineer, engineers have to go to university. There's no other way you can do that. That was my understanding of things as I grew up. And there was a lot of like, anxiety and like uncertainty on like, okay, how can I actually go further in my life if I don't do the degree? Because I went to university and found out that doesn't work for me. That style of teaching, like I can't be forced to be at 8 a.m. on a Tuesday in some room to learn math. That doesn't work for me. That's not how I learn. And generally, like learning all of these engineering topics from the math perspective first also doesn't work for me. Like I can understand mathematical concepts once I understand the concept in a different way.
That's really interesting to hear, because I'm similar. Tell me why this is important. Show me why, the real world application, and then let's talk about the details of what's actually going on under the hood.
Yeah,
It's
personally, I'm a big fan of from top to bottom learning. Some people have a completely different opinion there, but I think it
each
makes
their own.
Yeah, I think it really depends on how you learn, what you find interesting. Some people want to know the very basic fundamental things first, and that's totally fine. For me, that doesn't work. I want to know what is the thing we're going to do, and then break it down in all of its little aspects, because now I have an interest in learning all of these aspects, because I know what we're going to do with it, and I know why I want to do it. Like I said, motivation. So yeah, I think university is geared to a very specific type of person and mindset. And yeah, that's kind of gatekeeping, I would say, because you have come very, very bright people who will fail at university, but might be excellent engineers. Still, just need a different learning path. And we are very set in our ways there.
So just for my curiosity more than anything, is it the word engineer which is protected? And actually, you can't be a software engineer even without doing university.
Software is interesting. There is so the German word is Ingenieur, which is like very similar. I don't think there is a software engineer in the industry here. Typical is to call people engineer. The English word engineer, software engineer. But there is for if you are an engineer, people assume you're probably an electrical engineer.
Okay, interesting.
Construction engineering, that kind of stuff. And that's a protected title. There's engineering bureaus that you can open up as an engineer. And yeah, that is a protected title, and you have to have, I'm not sure if you maybe even need a master. I'm not quite sure.
But, okay. And how does that then work internationally? Because your new job is not in Germany. And are you allowed even to be an engineer as your job title with them, or is it really murky?
English word is totally fine.
I see. Sorry.
Yeah, engineer is totally unprotected. It's an English word, but the specific engineer, if you do it in German, that has meanings.
I hadn't appreciated that. Okay, apologies.
No worries. Again, people call themselves sub engineers here.
Right. Yeah. Okay. Interesting.
That's not protected.
Fair enough. And then so just to sort of pull on the education thread a bit further, for people getting into it, we've already established that university is not necessarily important, but even before you're at that level, you are currently sitting in a job potentially like young Timon doing graphics and animation and things, and all of a sudden you want to get into this more of an electronics type of a world, or mechanical design, or product design even. I guess it's sort of, how would you suggest how would you suggest approaching the new field?
If you find that yourself in that situation of wanting to start with electronics or software, do something. Really doesn't matter where you start, I would say. Fine. If you want to do electronics, I recommend something Arduino or something from Adafruit or something by Maroni. So many companies these days that make really approachable development boards. It doesn't matter which one you choose. Just do some tutorial with it and get the first thing going to get that feeling of what you can do with these things. Just do it as a hobby, I would say. Do projects, do ideas, do whatever comes to your mind.
Have a play, be curious, etc. It's the rush of even the first LED. The first LED you get to blink is fantastic. and even now, you get a new board for a customer, even professional work, and you get the LEDs turned on, and it's like, oh, wow.
Yeah, it works. I made something. I created something. It's a very, very powerful feeling. And I think very important to keep in mind. It's super frustrating. You will fail a lot.
Don't give up.
Fail often. It's good to fail. Failure is good. I learned everything from failure.
I 100% agree, and I often find that failure is almost stigmatized. Even
it's horrible.
Certainly
especially engineering, I feel it's you are the expert. How on earth were you not foreseeing every little thing? It's a completely flawed concept. How it's so far from reality. the first thing almost never completely works.
Yeah.
And that's so normal. And it doesn't mean you're incompetent in any form. It's just you miss things. Things don't always work in this way they are described. The people who made the things you are using made mistakes too. Mistakes happen.
This is a big thing for me, and that is that particularly software and to a large degree electronics, depending on what you're doing, it is so intangible. There is so much mental load to keep track of what's actually happening in this design or in this work.
Yeah.
You know, if it, I'll probably get shot down by the mechanical engineers, but if you're working on a thing which gets machined, you know, this, for example, it is a widget, and you can see it, right?
Yeah.
I can see it, I can poke at it. There are, of course, subtle things like tensile strength and whatever else, but that's it. Whereas with software, it's all ephemeral. It's all sorry, I'm ranting now.
I would say, so the big difference, it's abstractions. There's a lot of abstractions that we build upon, and there can be issues in each abstracted layer. And the thing you're holding up in the software equivalent is just a piece of software you've written, which is built upon this huge mountain of abstraction. And you have to understand all of that abstraction, how it plays together, and what issues it could maybe bring.
Yeah.
It has bugs too, you know. Again, nobody's perfect. So like,
yeah.
I think it's just the mountain of complexity. I think with mechanical, that mountain of complexity sits more in the manufacturing world. Whereas the design world, it gets really complicated too, I would say, in the mechanical world when you go to things like injection molding, where like it gets weird and complicated.
Being a bit facetious, but
but yeah, no, like say you're printing something, like once it's printed, it's there, and I know what you mean. And I think the difference is abstractions. Few abstractions are there. The manufacturing side is again software and hardware. That is complicated, but like once the functional thing, what we perceive as the functional unit, doesn't rely on all of these abstractions to work because it was just a one-off thing. Like it pooped out the thing. You know, we can't just how to explain what I want to say, but like, you know, with the software, the abstractions go everywhere. Like it's like the whole complexity of the injection molding machine doesn't go to the customer anymore.
Yes.
You know,
Yep.
It stays at the factory.
It's happened. It's now a tangible thing, and on with its life.
It always runs with you. It's always there. Can always break.
And there are things like with silicon, you know, you get a micro and all of a sudden you've got to deal with clock trees, and the documentation maybe isn't as clear as it could be. And how do I get this UART to work, for example, as a step one? A lot of the time, if you can use a platform like Arduino, that really helps with getting started, the foundational sort of make it work. And then once you've got comfortable with that, then start digging and get deeper and deeper.
Exactly. That's why I like top to bottom learning. It's the end goal is to make something. You don't need to, and then I would say it's normal to build upon abstractions. We cannot make things without these abstractions. And I feel like there's always these weird pretensions in engineering. We're like, oh, you're working at this level of abstraction. Now you're not an engineer anymore. You have to work at this level of abstraction. It's like completely arbitrary. And I feel like changes every decade. What is the acceptable abstraction level for being whatever engineer? You know?
I think there's a lot of shade almost thrown at things like Arduino for being, you know, what they are. And I wonder if maybe you saw some of this in particular at your media systems job, where you're working on potentially a tight schedule to get a thing done, and once it's done and it's happened, that's fine. You know, next project almost. In that kind of environment, why would you need to do everything yourself from the ground up? You know, it'd be much more beneficial, much more time efficient.
Yes. So like it would be absolutely dumb not to do.
Well said.
So you have business aspect always. Engineering is always designing something to a specific constraint. That is engineering at the end of the day. You know, you can do, like, there's this saying, I'm not paraphrasing here, like everyone can build a bridge, you know, with enough money and enough resources. You can just, you know, fill the whole river up with stone, whatever, you know. Problem solved, there's a bridge now, you can walk over the river. But that's not, you know, engineering, because there was no constraint at all. The engineering aspect is, okay, you have a budget, you have a physical, and as some design constraints to like how you can do it, and you have a time constraint, like these three, like technical, money, time.
Yep.
And in my industry, money and time is most of the time the biggest aspects. That's what the customer is interested in. They just want something to work, and it has to be mostly cheap and super. We have to do it very, very quickly. So sure, I can write my own driver for this thing, but why? That is something that works. It's maybe not the perfect design. Maybe the software is not, the driver is maybe a little shoddily coded. I can see that, but it doesn't matter for this situation. I'm engineering for this constraint of like, it needs to work next week, and I have to do it with this X amount of money. My work time is worth money, so I cannot spend all of the time on it, So like I have to choose. I have to pick my battles. And Arduino is great there. There's a lot of problems with Arduino, but I feel like people criticize it for the very wrong reasons. It's not because it's too simplistic or it's too slow. People sometimes say, maybe in the AVR world, that was still true, that the hell was a bit slow, but it gets difficult with Arduino if you do like large scale projects. Like there's no modern infrastructure really there to like make that work as a team. It's meant for like a single person working on a prototype, and it works very well for that. And the Attie
and learning as well, which I think is so important.
They use shit like that's totally too, but there's that you just open the code in a different Attie. It's fine.
We had a comment from Ian just now saying engineering is the discipline around the fun, and I think that's a fairly reasonable way of putting it. Apologies if you can hear that helicopter.
Oh, it's fine for me. Yeah, and yeah, I was completely tied to Arduino. I was always wanted to do something with Zephyr, for example. I can't use it at my day job, or at my last day job. It's just I was completely responsible to choose that because there's a lot more bootstrapping involved than with Arduino.
Learning curve and getting up to speed and making it happen.
And I think like, okay, let's say I'm already up to speed with Zephyr, but just the amount of drivers for things. So like a customer comes with a super crazy idea. I have to figure out within a day on how to do it, basically, to give them an estimate on like, can we do it actually in this time frame? How much will it cost? Like I have to get up to speed on the problem space immediately, basically, sometimes within the meeting.
Right.
So I cannot, like, if there's no driver for it, it's already like way low in the list. With Arduino, there is a bazillion drivers because that's what people use for prototyping.
Yes. Yeah.
And so even if it's a shallow driver, okay, like I can fix that, but there's something that already kind of works at least.
Exactly.
I have a starting space. That's good. There's something proven, and that's what I'm looking for. Are there proven things for the things we could use to solve the customer problem? And I have no choice but to use Arduino because that's the ecosystem, the HAL. Let's call it that, because I mean, there's a lot of things called Arduino. There's the boards, there's the company.
Absolutely.
At the end of the day, we're talking about a specific HAL that people write code for.
Yeah.
And I've made a lot of Arduino compatible boards because on the hardware side, often you need different form factors. But using that HAL is very, very important for me in that industry because time is of essence and money is of essence. So I need to find the proven things very quickly. And all these things like Zephyr, they are great if you have a product where our engineering team now gets together to like, we have these specs here, and like, okay, we can try out a lot of different like sensors that do the same thing. Which one is the best? And then like make drivers for that. Like there's the time, there's the budget for that, because that's what's needed in that case. Because you need to find out the correct, like not just something that works and does it kind of, but you need the very specific thing that works the best, it's cheapest, whatever. You have to evaluate a lot of things, and there's the budget for that, the time and the money budget for that, and that just does not exist in this space. So Zephyr as a concept just falls out. And sure, maybe at some point there will be a lot of drivers for Zephyr, but I'm doubtful that we'll ever reach that mountain of drivers that exist.
I think the incredible plug and play nature of Arduino, and the fact that you can effectively, I think you can go through the menus and search for something, and here's a driver that someone's written. It's like, okay, I'll have that.
And then like also the ecosystem of companies, of course, Adafruit, Spark,
of course.
Timon, like they target these prototyping environments. Also CircuitPython. Not suited for everything, but it's great. Sometimes I do like a very quick, like, okay, try something out with CircuitPython. It's often too slow for some things, but then do it in Arduino afterwards. Like even there, I go from some abstraction to another by now, because we now have CircuitPython. It's like even higher abstraction than Arduino. But it's now an even more iterative process, because I just have to save code, don't have to compile anymore. Like that saves me so much time, because I have to try out interactions. Like I have to constantly tweak values. So like just save, for example, is a huge time saver for me. It's not the most suited for like embedded engineering at all. CircuitPython is not made for that, but it's perfect for prototyping.
Absolutely, yeah.
And choose the tool for the job. That's it. And don't judge people for choosing the right tool. That's weird. Don't do that.
And don't even demand justification. Just accept it. Yeah.
And so,
sorry, I was just going to say, your new job was product design. Your previous job was almost sort of rapid prototyping type thing. How do you think that's going to be for you, moving potentially quite a large mindset into a new space?
So like that's interesting about my job is like while we do prototypes, we'd sometimes have to maintain them for 10 years.
Okay.
So like I have projects that I started when I was just starting out, written very bad code, and still have to maintain that code and fix
coming back.
Because customers deploy these systems, like especially museums, are like really long running things. And so I had to actually, make something very quickly, but make it also very reliable and future thinking, and like actually the mindset you have for product design, I would say, where like you have to anticipate usage. Is the customer just yanking the power out of the thing when they shut it down?
Yeah.
And okay, I have to like account for that because we can't make a safe shutdown. And the systems are super complex these days. Like I basically do IoT. I'm an IoT developer at the end of the day. Sounds weird, but yeah, I do museums IoT. They have like dozens of systems running there that interact with each other. They have content management systems. It's a very cloudy, but like all local. So you have to deploy servers and super complicated network setups, and a lot of Linux embedded systems that do one job and get like updates and have update mechanisms. Develop tools to make all of that easier, because doing that from scratch with every customer is kind of a waste. I feel like a lot of the methodology and the thinking and like architecturing is actually kind of similar. So I feel like comfortable about that. And I think the biggest difference is like, mostly like, okay, take this working thing and, go to production, which then means certifications most of the time, I would say. Like if it's a medical device, for example, vet the thing. And I'm not sure if I will be part of that product. Like the product design I'm going to do is a little bit more on the R&D side. But also handing that over to manufacturing and like having in mind that need aspect
where it could go in the future.
Other team might take over to like, okay, they don't have to start over because I gave them a ton of crap, but have an idea of where they have to go and like have a good input.
Nice.
But, I feel quite at home there, and in my hobby time, in my night job, I've done that now for a couple of years as well. So like I felt like the natural progression to like, okay, just I've done that enough. I've seen everything in the media industry, and I want to see more in product design now.
Yeah, fair enough. I think we're coming towards the end of time. So if anyone has any questions, please feel free to pop them in the chat, and we'll get Timon to answer some. In the meantime, though, we could carry on talking about almost anything. Anything particular for you stood out of our chat that you'd like to revisit, or anything new? Or some leaving thoughts?
My quick touch up on education. Like, don't feel intimidated by people saying you need this and that piece of paper. Some companies require these pieces of paper, but I've seen it more and more that some just require experience. It's hard to get your foot in the door. That's what the base of paper most of the time is for. Get your foot in the door. But there are, get contacts, get to know people. That's the best way to like get into the industry if you're interested in that. If that's the way you want to go. Twitter was great. Like I found my no job through Twitter.
There you go.
And yeah, you can learn all of these things in whatever way you want. University does nothing special. There's no magical knowledge shared there that you can't find out yourself. And the only thing that's different, there's a specific structure that is given to you. If you don't go to university, you'll lack that structured course. And you can have some gaps there, I guess, but it really depends on how you learn and what you do.
Yeah, and that said, a lot of this sort of stuff is available as online courses and various other things. The IET, for example, require, I think it's called continuous professional development, CPD, and probably a lot of other industries and professions out there require that as well. But I've seen trying to prove that you have attended training courses when actually they're a YouTube video, for example, can become really difficult. It's a really interesting problem.
Yeah, but I mean, it kind of shows how ridiculous that is because, just because the person went to this place and listened to something technically.
Maybe listen.
Just says they were in the same room. Did they actually listen or learn something? Who knows?
Yeah.
So that's I think it's a general problem of like these assumptions of like, if somebody did a course, they know something. Maybe they know even more than the course offered because they researched a lot more than was necessary.
Yeah.
But I think we have to rethink on how we certify people for something.
And actually,
certification is necessary
to exams and everything as well, for school time exams, where someone's ability to remember a whole chunk of information for the day might outstrip someone's inability to remember it for the day.
Yeah.
Even though that person who can't remember all the details for the exam might have a far better, deeper understanding of what was covered in the course, for example. It really, really winds me up that side of things.
No, for sure. Yeah.
Cool. All right. I think we've had no questions.
Yeah.
So we might close up then. Thank you everybody for joining us. I hope it's been entertaining and insightful. And thank you very much, Timon, for our first show.
Thanks for having me.
Yeah. Thank you very much. Okay. Bye all.
Bye.